we're jumping into reflecting points in the coordinate plane. Now we've talked about ordered pairs like X and Y. We talked about the X and Y axis. Now we're going to talk about something, we're going to step it up a notch and talk about reflections. So when we're thinking about reflections, some of you mentioned the different places where we see reflections in the real world. So my first thought is, when I'm thinking of a reflection, my first thought was, well, I see a reflection in a mirror. Another student mentioned that they see reflections in the water or a window or any other types of surface. When we see reflection, basically what I want to point out is it's an image bouncing off of a surface. That is the reason, sorry, that's an E. That is the reason in math we call these reflecting points. Because just like in science, when you learn about light fragmenting and bouncing off of things like a laser. So I'm going to draw my really pretty picture of a mirror, like in Beauty and the Beast when she has a handheld mirror. It's not a magnifying glass. Don't judge my art. If I pointed a laser beam at the mirror, it would reflect into the opposite direction. And if I pointed the laser in a different angle or from a different starting point, and it would bounce off in the equal opposite direction. Not the best visual representation, but you get where I'm coming from. So you can reflect, I'm going to use a different color. You can reflect ordered pairs. That's these guys right here in the X and Y axis. So we know an ordered, oh, that's an E, sorry guys. An ordered pair is an X and Y coordinate placed on the coordinate grid. Now we're talking about reflections. So it's important you know where these are first. You have to know where you're starting. You got to know which way the laser's being pointed in the mirror to know where it's reflecting off or bouncing off. Another term for a reflection is a mirror image. Hence why my first example of where I see reflections in real life is a mirror. So, we're going to talk about reflections on the x-axis. Kind of hard to see, but I'm drawing blue, so it's color-coded with our notes. And then our x-axis, we'll see what's reflecting off of this. And then we'll see what's reflecting off of our y-axis. I'm going to use green to color code with our notes. So let's look at the first one. It says B. B is a reflection of A in what axis? Well, let's find it. Here's B, and here's A. Well, thinking, I'm going to zoom in. I'm trying to think, where would it look like they are equal distance away from each other? It doesn't look like as if I folded the paper in one direction. Let me stop. I'm getting confusing. I want to point out something. If I were to honestly fold the paper like this on the x-axis, A and B would meet up. They are mirrored away from this line. They're both one space away from the x-axis. So that means they are a reflection off of the x-axis. Please put that there. So now I'm going to look at D is a reflection of C in what axis? Well, they're both 1, 2, 3, 4. 1, 2, 3, 4 spaces away from this as their middle point. They're reflecting and bouncing off the different directions from there. I would say this is where their mirror is. So they are a reflection in the y-axis. Make sure you have all this. If you need to pause, go ahead. To reflect a point in the x-axis, the x-coordinates remain the same. So I'm going to go back up here. A and B. A is 2, comma, it went up 1. B is 2, comma, it went down 1. So looking at these ordered pairs, I have positive 2, positive 1, positive 2, negative 1. If the x's are the same, that means the y-coordinate has to be, we would say different, but the mathematical term you're going to add to your notes, I'm going to zoom in for this, it is called negated, to make negative. So to reflect the point in the the x-axis, the x-coordinate remains the same. Got it? And the y-coordinate is different, negated, or opposite. We're familiar with this term. These are all talking about the same thing. What's different between these two? This positive one and this negative one. Those have to be different because the x-axis, that's where the reflection's coming from, the x's are the same. 2 and 2. The x's are the same. That means that's where the reflection is coming from the x-axis. To reflect a point in the y-axis, the y-coordinate remains the same, and then the x-coordinate is different, negated, and the opposite. They all mean the same thing. In this case, in this context, in this situation, talking about reflections, if I say the coordinates are different, they are negated, they are the opposite, I'm talking about the same thing. So we're going to graph these next ones. I'm going to graph 4, 5 on the grid below. I'm going to stop and do that. So I have to find my elevator. You got to mark X, then Y. So in this case, graph 4, 5. So I'm going to start at the origin and go over 1, 2, 3, 4, and up 1, 2, 3, 4, and 5. I'm going to graph that. I did that. Then reflect it in the x-axis. I'm going to circle that. What are the coordinates? So if I'm reflecting off of the x-axis, that means the x's are going to stay the same. So that's going to be positive 4. What's the opposite of positive 5? Negative 5. Those are going to be the new ordered pair reflecting off of this, off the x-axis. So there's 3 things you need to know when you're looking for reflections. What is your first set of coordinates? I'm going to put find. Let's do that. Find first set of coordinates, which I did. I plotted it. Then find the axis that will reflect. So first find the set of coordinates. Did that. Find the axis it will reflect. It was the x-axis. Did that. Then negate the other point is what I want to say. So in this case, it was 5. I had to negate that and make it negative 5. So let's see if on the grid it proves my point. If I'm reflecting that exact number of spaces from the x-axis, I'm going up 5. Now I'm going to go 1, 2, 3, 4, 5. And look at that. That is positive 4, negative 5. Positive 4, positive 5. Those are reflections off of the x-axis. I found my set of coordinates. I found which axis. They set off the x-axis, which gave me a hint. Oh, I know which one needs to stay the same. It's from the x-axis, so the x's stay the same, and they did. And I negate the other one. And I just put other one because sometimes if it's the y-axis, that'll influence which point I am negating, making different, making opposite. All right, let's try the next one. Now we're going to graph negative 2, negative 4. I'm going to use a different color. I'm going to do my orange. So negative 2, go left 2. Negative 4, that means I go down 1, 2, 3, 4. And now it's asking to reflect on the y-axis. So that means instead of, I'm going to write this down here. Sorry, guys. I just realized it cut off a little bit up there. So if I had -2, -4, the y-axis is what I'm reflecting on. That one's going to stay the same. So now I need to make -2 its opposite. That's +2. So if I go +2, 1, 2, 3, 4. There we go. That is a reflection off of the y-axis. As if they're bouncing off this mirror, that is the y-axis. All right, guys. When you're ready, you can turn your papers over and work on this set of problems. Sorry, my Sharpie went a little bit through. You're going to graph each point on the grid, then reflect the point in the x-axis. So this whole top one, you're only reflecting off of the x-axis. And then I'm assuming the second one, you're going to graph each point, and then you're only going to reflect the point on the y-axis. So write this down so you don't accidentally plot incorrect reflections. And then the very last one, they're going to give you the ordered pair and tell me, what would I write for the reflection on the x-axis? And on this column, what would I write for the reflection of the y-axis? When you're done, get a check from Miss Madera, and you are ready to go.